Understand this part, right? So whenever we are seeing the energy levels will be telling you that what is the energy. First energy level will be having lower energy, second energy level more higher, third more higher, fourth more higher, right? Did you get
Yeah.
my point? And we know that electrons are filled by that particular the laws which are there, right? In the 2, 8, 8, 18, or whatever, right? Isn't it? Now we have to go. Now we have to understand about this important part, electromagnetic spectrum, right? We have to see that any sort of light, right? Sorry, any sort of energy, any sort of radiation, right? Any sort of radiation can be segregated into different forms, right? Radio waves, microwaves, infrared waves, visible light, ultraviolet light, X-rays, gamma rays. Did you understand the point, right? What is happening? Any sort of radiations can be divided into many parts, right? Isn't it? Radio waves, microwaves, infrared ray, visible light, ultraviolet, X-rays, right? Gamma rays, right? Isn't it? This is the form, right? They'll be having, right? Now, here is a very important concept we have to master is that if you see that when we talk about the important part, any radiation can be determined by its energy, right? Isn't it? We studied this earlier. E is equal to h nu, right? What is
Yeah.
h? What is h over here? H is called as the, tell me, Planck's constant, right?
Thanks.
Planck's constant, right? Nu is the frequency of that wave, right? And it's fine. So we can know that energy is directly proportional to the frequency. Do you agree with this, right?
Yeah.
Energy is directly proportional to the frequency of that wave, right? Isn't it? That's very simple, right? We are getting this, right? Now go to the next part, right? If you see when we talk about this, right? We have to also say that there's a relation that what is electromagnetic radiation? Electromagnetic radiation are those radiations which travel at a speed of light. Is it clear? Understood? Do you understand this thing? Which
Yeah.
travel at a speed of light first, right? What are electromagnetic radiation? Electromagnetic radiations are those radiations which travel at a speed of light, number one. Clear? Second, which will be traveling in the form of waves, right? Isn't it? Fine. Isn't it?
Yeah.
They don't need a medium to travel. Did you get my point? They don't need a medium to travel. Understood this part, right?
Yeah.
Understood?
So
What is electromagnetic
yeah.
radiation? Electromagnetic radiation is the radiation which travels at the speed of light. They travel in the form of the waves, and they do not need any medium to travel. Understood this part clearly? They don't need
Yeah.
any medium to travel. And whenever we are seeing that any electromagnetic radiation, the what do you mean by the word called the wavelength? Wavelength is the distance between two crests. Understood? Clear? This. Or two troughs. Understood? Clear? So this is called the wavelength. What do you mean
Yeah.
by the word called the frequency? Frequency is the number of waves
That
passed
pass
into a
to
single
certain
point
point
per
per
second.
second.
Per second,
Yeah.
right? Wonderful, right? Per second, right? So that's the important part we have to master, right? The next important thing is that if you see that the wavelength of any electromagnetic radiation multiplied by its frequency will be always equal to the energy of that light. Sorry, will be equal to a constant. What's a constant? Constant is the
Speed of
speed of light, right? Clear? Understood?
yeah.
If you multiply the wavelength multiplied by the frequency, right? This multiplication will be giving what? This multiplication will be giving you the speed of the light. C is the speed of the light. Speed is constant, right?
Yeah.
Clear? This is clear to you? Fine.
Yeah.
Now going to this thing. Now, if you see when we talk about when we talk about this, right? We have to understand a very important part that whenever we are segregating the different electromagnetic radiation based upon the energy, so left to right the energy is increasing, right? Clear? Means radio waves. Can you think of this radio waves come to our cars, right? FM radio, AM radio. Understood? This clear to you?
Yeah.
Least energy, right? Least energy. It's nothing harmful. Microwaves we are using where? Tell me. In our microwaves to cook the food.
Cinema.
Infrared radiation is using where? In the remotes, TV remotes we are using, right? Remotes or AC remotes, whatever, right? This
Yeah.
light we can see, right? This light, visible region. This visible region is actually segregated into what? They're segregated into
Really.
red in the lowest energy and violet in
Yeah.
the highest energy, right?
Nice. Yeah.
Then towards the violet, we are having ultraviolet, right? Isn't it clear? Do you get my point? Towards the violet, we are having ultraviolet, right? And we are having what? We are having X-rays, gamma rays, right? Clear? Understand
Yeah.
this part, right? This is clear to you. So this is a very important portion we have to master, right? That whenever we are seeing this, right? You can understand that from left to right, the increasing energy is there. And we know that E is equal to h nu. And we know this particular formula also. Lambda into frequency will be equal to speed of the light. Now can we rearrange like this? C divided by lambda is equal to nu. Can we write this? Can we do this?
Yeah.
Can we write this equation in this way also? E is equal to hc by lambda. We can write this. Agreed?
Yeah.
Fine. Now over here we have to remember that. So we can find what? We can find that the energy of any wave is directly proportional to the frequency of that wave. Got it? Understood?
Okay.
We also know that the energy of any wave is inversely proportional to the wavelength. Got it? You get my point? Is inversely proportional to the wavelength. Agreed? Got it?
Yeah.
Fine. So that's a very important portion we have learned, right? Now the next part is that if you see when we talk about talk about this, right? We can also we can know a very important thing, that if we see that suppose we have tried to take a hydrogen gas. When we take
Yeah.
hydrogen gas at a low pressure, right? Low pressure in a sealed tube at a very high voltage, right? This gas will be starting to glow pink. Got it? Did you understand my point? We take hydrogen gas at a very low pressure and we subject it to a very high voltage, right? Isn't it? Very high voltage, right? This gas starts to glow pink. Got it? Is it clear? Fine. Is it clear? So
Yeah.
when this light which is emitted, right? Light is emitted by this gas is called as emission spectrum. What's emission spectrum? Light emitted by a gas under what conditions? Under low pressure and high voltage. This light is called as an emission spectrum. Easy, easy. What is emission spectrum? You'll be understanding why it is glowing, right? Is it clear? This light which is emitted by the gas, this is called as the emission spectrum, right? Fine. Now,
Yeah.
next important thing is that if you see this light, with a spectroscope, right? If you magnify this, right? If you magnify this, right? If you magnify this with a spectroscope, right? Isn't it? If you magnify this with a particular spectroscope, right?
Yeah.
This will be seen as what? This light will be, pink light will be seen as fine lines in a black dark background. Got it? Is it clear? Shall I come back again? When we take hydrogen gas at a low pressure at a very high voltage, this gas glows pink. This is called as the emission spectrum. When we further see this gas with a particular magnifier, a spectroscope, this pink color is actually seen as series of fine, sharp lines at a dark background. Clear? You get my point? Understood? This is called as a line spectrum. Understood? What is a line spectrum? Line spectrum is a series of sharp, bright lines on a dark background. It's called as a line spectrum. Understood? Clear to you, right? Did you get my point, right? So that's a very important point we have to think about, right? Isn't it? Did you get my point, right? Now, going to this important part. Now, if you see that when we talk about when we try to talk about this, right? We have to understand that this is a very important portion we have to master, right? Isn't it? Fine. Now, going to the next part, you will be seeing that this question comes in a board, right? This question comes in a board. Can you just try to cut this question? This question. This part comes in a board, right? This part. This part. Huh? Please cut this part and send it. Or shall I zoom out so that you can get better? Now can you do this quickly? Done?
Yes.
Thank you. Did you get this point? What is line spectrum? Line spectrum is where you're having a series of sharp, bright lines on a dark background, right? Clear? And we have to see that the lines is getting closer at a higher frequency. Is it clear? Or higher energy. Can you see this? The gaps is actually closing down. Can you see this? Isn't it? The gaps is closing down. Got it? So the line gets closer at a higher frequency or energy, right? See, this you have to maintain, right? This chart you have to fix about, right? This chart. Can you see this? These are all the electromagnetic actually spectrum you're having. Left to right is what? What is left to right? Tell me. Increasing energy. Got it? Similarly, if you see these lines, these sharp bright lines will be closing down at a higher frequency, right? Is it clear to you? What is this thing? Will be closing down at a higher frequency or energy, right? Did you get my point? Understood this part? Now, you see, you have to see why, right? You have to see why. Why does it happen, right? The series of bright line gets closer at a higher frequency, right? Now, I forgot to tell you a very important thing. You know what? If you see the atom, right? If you see the atom, this is a very crucial thing you have to master. These are the energy levels, right? These are energy levels. And remember one thing: when you go from the nucleus to the outermost like this, right? You are going like this. The gaps will be closing down. Is it clear? Understood? These gaps. Can you see this? The gaps will close down. Understood this thing? This concept is clear?
Yeah.
The energy, is it clear to you? Did you get my point? Understood this part? The gaps will be closing down, right? Clear? Got it? The gaps closes down, right? Understood this part? The gaps will be closing down. See, it closes down, right? Fine.
Yeah.
Understood? So it's a very important point we have to nurture, right? The gaps closes down. Now you see that suppose when you excite electrons, right? Suppose you have taken 2 grams of hydrogen gas, right? How many particular molecules are there of this hydrogen gas? Can you guide me? We can find out the moles of the hydrogen gas. How can you find out? Tell me. Mass by MR, right?
IMI.
So 2 divided by 2 is 1 mole. 1 mole is how much? 6.02 into 10 to the power 23, right? Understood?
Yeah.
Got it? Molecules are there. Agreed? Fine.
Yeah.
You get my point, right? Understood this point, right? So that's an important thing we have to nurture, right? Right? Is it clear? Got it? So that's a important thing we have to understand over here, right? Agreed? Fine. Now over here we're seeing that if you see that we have taken 2 grams of hydrogen gas, that's huge. This amount of molecules are there, right? 6.0 10 to the power 23, right? Now mind, you have to remember one important thing, that you know what? Hydrogen has got one electron, right? Isn't it? Hydrogen has got 1 electron. When you excite hydrogen, right? When you excite hydrogen, it can be possible that the electron will be jumping over here and sitting over here. It can be possible that some electrons will be coming over here, some are coming over here. Understood? While suppose this electron is coming back, right? This electron can come back in many ways, right? It can come to this energy level, wait for a certain time. Means ultimately it has to come down to this energy level 1. Agreed. But the journey can be break journey also. It can here, can over here, and ultimately it comes over here, right? Got it?
Yeah.
When you excite, now suppose tell me, suppose you are exciting this electron, right? Suppose it's exciting this electron here. Exciting this electron. Suppose this energy level 1 is suppose 20 of energy, right? This energy level, suppose the fourth energy level is suppose having energy level of energy of 75, right? Now mind, can you tell me that if you want to excite this electron and go to the 4th energy level, how much energy do you need?
75.
75 minus 20.
20.
Okay. This amount of energy it takes. Understood? It takes in. And when it comes back, right? Mind, can you just write down there transition metals? No? Transition metal, write down. When it comes back, right? Transition metal is mentioned, right? When it comes back, right? Like this, right? When it's coming back, right? This will be releasing exactly 55 of energy. Agreed?
Yeah.
You get my point? It will be releasing exactly 55 energy. Is it clear? Got it?
Yeah.
Understood this part? Exactly 55 energy it will be releasing. Understood? And this energy which is released will be fixed. Why? Because the energy level gaps is fixed, right? For any element, right? This gaps is what? Like a fingerprint, right? Clear? And the gaps will be closing down. Understood? This gaps close down. Got it? Now if you see that why did we see that spectra? First thing is that see. Suppose mine electron is in the 6th energy level, it's coming down to 2nd energy level, right? So how much will it actually release energy? Delta E 6 to 2, right? 6 to 2. Now if it is coming from 3 to 2, how much energy will it actually release? Mine?
Delta E 3.
3 to 2. Understood? 3 minus 2. Understood?
Yeah.
Can you tell me that which energy is more? 6 to 2 or 3 to 2? Energy released?
6 to 2.
6 to 2. And we say what from left to right, what happens? The energy, tell me, increases. See, it is at a higher energy, this line is seen. Is it clear?
Yeah.
This is seen at the lower line. Understood? Clear? Got it? Now tell me one thing. When an electron is coming back from 5 to 2, what will be the energy? 5 minus 2.
5 minus 2.
Understood? Yeah. And this difference between this energy and this energy will be how much? Exactly equal to this gap. Agreed?
Yeah.
You get my point? And that's the reason we are seeing this gap. Got it? You get my point? Please stop me if you don't understand. Is it clear? Shall I come back again? Tell me. Come back again?
No. The gap is there
E
because
is 6 minus 2, and this is how much? This is
5
5
minutes.
minus 2. Understood?
Yeah.
So this will be having a gap of how much? Difference of energy exactly equal to this. Agreed? Understood? You get
Yeah.
my point? Now 5 to 2 and energy 4 to 2 will be having energy gap of how much? Tell me. Exactly equal to this. Understood? That is reflected over here. Got it? Understood?
Yeah.
When we go from the lower energy level to higher energy level, what happens? The gaps between the energy levels does what? Tell me. Closes down or increases?
It closes down.
Decreases, right? Or closes down, decreases. Understood? Clear?
Yeah.
That's the reason we are seeing this, right? That the gaps between the line spectrum, they will be closing down at a higher frequency, right?
Yeah.
Clear? You get
Yeah.
my point? Absolutely clear of this part. There's no doubts over here. Now, fine, got it. Now, mind, we have to see that when we take hydrogen spectrum, right? When we take hydrogen spectrum, in the hydrogen spectrum, what do we see? In the hydrogen spectrum, we are seeing that if you see that whenever we are seeing the hydrogen spectrum, hydrogen spectrum look like. Just give me a minute, 1 minute. See, mine. There's a very good question of your boards. Have you typed it? Now, right now, don't write down old PSN OP page 73. Yeah, write down old PSN page number 73. Huh? This fine. Huh? Just few more minutes. Huh? Just see. Now see, if you see that whenever this is a hydrogen atom we are taking, right? 2 grams of hydrogen atoms we are taking, how many? There are 6.02 into 10 to the power 23 moles of electrons, right? Electrons which are there, right? Now, what happens when you excite an electron, right? Mind, when you excite an electron, right? Now, can you see this? The electron can, when it's coming back, it can come here, take a rest, come over here, take a rest, and ultimately come over here. Or the electron can come over here, take a rest, come over here, take a rest, and come over here. Understood? Clear? You get my point?
Yeah.
Understood point. Finally, you can also see that the electron can come over here, take a rest, come over here. Agreed? You get my point, right? You get my point, right? So these are
Yeah.
the ways by which the electrons can come back, right? Is it clear to you? Come back, right? Isn't it? So now now we have to see that there's a scientist called a Lyman. Lyman did what? Lyman said that when the electrons are coming back, all electron jumps from n greater than 1 to n equal to 1, right? N greater than 1 to n equal to 1 will be seen as sharp lines, 5 lines, right? Indeed. In the ultraviolet region. Can you tell me the jumps? Which are jumps? 2 to 1, 3 to 1, 4 to 1. Can you see this? 2 to 1, 3 to 1. Understood? 4 to 1, 5 to 1, 6 to 1. These are observed in the ultraviolet region by the scientist Lyman. This is called as Lyman series. Clear?
Yeah.
All electrons jump from n greater than 2 to n equal to 2 is seen as 5 lines in the visible region of the spectrum, right? This was observed by Balmer, and this is called as Balmer series. What are the transitions? Can you guess? You tell me. What will be the all the options? Tell me. Tell me.
Check.
3 to 2, 4 to
3
2,
to 2,
5 to
5 to
2,
2,
6 to
6 to
2,
2, 7
7
to
to
2,
2.
8.
Got it? That's all. Five lines you have to connect, right? Clear?
Yeah.
Now,
Yeah.
now there's a scientist called Paschen. Paschen has seen what all energy jumps from n greater than 3 to n equal to 3, right? Isn't it? To n equal to 3. This is seen as 5 lines in the infrared region. Please note down this, right? Clear? Infrared region. Got it? You get my point? In the infrared region, right? Agreed?
Okay.
Infrared region. Understood? And this is called as Paschen series, right? Clear? Get my point? Understood?
Yeah.
Get my point? Now, what did I tell you? That the energy levels does what? Tell me. The energy levels, they decrease the gap. Understood? Now remember
Yeah.
one thing, that hydrogen has got one electron, right? That does not mean that the other shells are not there, the other orbits are not there. They are there, but they are vacant. Understood? Clear? We have got orbits till n equal to infinity. Is it clear? Do you get my
Yes.
point? So ultimately, if you see these, that if you are seeing that at a much higher energy level, that the energy level almost merge. Understood? Clear? Almost merge. Did you get my point? Right? Understood?
Yeah.
Right? You get my point? Now we have to know that can we find out the ionization energy by some energy we are giving? Yes. We can find out the ionization energy by the energy we are supplying, right? How? Can we supply a energy in such a way that the electron is going, first tell me that what's the meaning of ionization energy? Ionization energy is the energy to
It
take out
is.
an electron and throw it outside an atom, right? Outside. Understood? Outside an atom. Understood? Clear? And throw it outside an atom. Understood? Clear?
1 mole of gaseous ion.
That's another thing. In layman's language, we are taking out electron, throw it outside an atom, completely outside. That's ionization energy in layman's language. Can we say
Yeah.
it in this way, that we can also see that the ionization energy is the energy needed to take out an electron to put it into the n equal to infinity? It's outside an atom, isn't it? Do you get my
Yeah.
point? Now we can calculate the ionization energy, right? We can calculate the ionization. Have you written old Pearson page number 73? Have you written?
Yes.
Written, no? That's 1 minute. Then 1 minute, just give me 1 minute. We have to go to the new Oxford book, huh? Now next. No, 1 minute, huh? Give me 1 minute. Just give me 1 minute. Just give me 1 minute. A second, huh? I'll just open the book quickly so that I can tell you where it is. This page number 58. Can you send me a message, please? Uh, new Oxford, New Oxford, page number 58. Worked example, most important. Write down. 57, 58, most important. Mind you, do this, right? Please, huh?
New Oxford
New
5750.
Oxford 57, 58. This will be coming in exam. This has come. This has come, right? Clear? This has come. See, now we will be saying that the spectral lines converge at what? The spectral line converge at this, right? They're saying, right? In the emission spectrum, right? We have already told the wavelength, right? Wavelength. Now, they're saying that what the first ionization energy. I told you what? That if you see the energy levels, right? The energy levels will be converging, right? At a higher energy level, right? Isn't it? So can we take a machine where we can measure the energy and place the electron over here, right? We need energy to place. We can easily find out the delta E, isn't it? Understood? From the machine. The data is given. See, the wavelength is given. How much wavelength of light was used for the machine to, means the energy needed to take out the electron and put into the put in the put in the n equal to infinity. Is it clear? Did you get my point? Right? Is it clear? So from here, they are giving you the particular wavelength. Can we calculate the frequency? Frequency is equal to c by lambda. Can you calculate this? Is it clear? Do you get my point? Understood?
Yeah.
From this wavelength data given of the energy needed to take out this electron and put it into that energy level, which is actually n equal to infinity, right? They have
Yeah.
given the wavelength of that energy. But can we calculate the frequency? Yes. C is what? Speed of the light, isn't it? C, isn't it?
Yeah.
See, can you see this?
10
You do
power
this,
8.
right? Can you just cut paste this quickly? Cut paste this question quickly. Cut paste this question. One of them will be coming, huh? And cut paste this question. Have you done?
Wait, can you go back? Yeah.
Yeah, you can cut paste. Yeah, just yeah. Can you do this? When you complete, you tell me, huh?
That's the first one. So I've ended it.
Fine. And this one, do it.
Which one? Okay. Sent it.
Fine. Done. Do practice this. See, easy. Once we find out the frequency, see, lambda is given over here, meters, right? And C is equal to nu lambda. Huh? We can find out the nu. We found out the nu, understood, in hertz. Then we plug it to what? E is equal to H nu with the
Energy.
energy, isn't it? The our first ionization energy they're asking that. What's the energy to take out the electron and put it in the n equal to infinity?
Yeah.
Understood. Then we do what? We plug it into E is equal to H nu. What is H? H is Planck's constant.
Thanks.
6.16 10 power minus 34. Memorize this, right? Joules. This is very important. Joules. We multiply it by the frequency. We get what? We get the energy needed to take out. Please tell me. One
One.
electron only. One
Yeah.
electron. You're putting up one electron in that energy, right? Got it? We got that energy. But what is the definition of ionization energy? Tell me. Energy
1
needed to
mole.
take out one
Say,
mole of electron. And ionization energy is in kilojoules also.
yeah.
So for one electron is this. For 1 mole of electron is how much? Multiplied by 6.02 to 10 to the power 23.
Yeah.
Understood? We get joules. Now we have to get in kilojoules. What we do? We divide by 1000. Right? Clear? Understood
Yeah.
this part? Did you understand this part, right? Understood? Huh?
And
Is it
yeah.
clear to you? So this is very, very important, right? This is very, very important, right? Now actually going to this thing, we also have to understand that when we talk about when we try to talk when we try to talk about this, right? Can be given opposite data also. You can given me first ionization age, right? Understood also. So you have to divide it by the number of moles or the 6.0 10 to the power 23 to get one atom ionization energy. Understood? When you
Yeah.
get that energy, we have to plug it into this formula E is equal to H nu. Then we will ask to find out the frequency. Got it? Or understood? Vice versa question will also be there. First
Yeah.
ionization will be given. You have to calculate the wavelength and so on. Right? Do you
Yeah.
get my point? Fine. Understood?
Yes.
Done over here? Fine. Understood? Mine. So
Yes, sir.
thank you so much, mine. I'll be just connecting with you. Fine.